All right, so today we're going to be looking at kind of a modification of the last functional group we did, the amines. These ones will be called the amides, and they're going to follow rules very similar to ones that we've already gone through. So this molecule over here on the left should look very familiar. We know that there's 1, 2, 3, 4 carbons in it, and on one of those carbons we have an alcohol or a hydroxyl group, and this aldehyde, this double bonded oxygen at the end, connected to the same carbon. And hopefully we remember that this right here was a carboxylic acid. With the super messy writing. All right, carboxylic acid. When we had both of those attached to the same carbon, it was its own unique thing. Like this wasn't an aldehyde with an alcohol group on it. I mean, it kind of is, but when we named it, we called this 1, 2, 3, 4 butanoic acid. All right, because it just changed the chemical properties of this hydrogen here. This setup makes this hydrogen just pop off really easy, making it very acidic. And we're going to see the same thing occur when we have an aldehyde on the same carbon as an amine group over here. So this configuration right there, this is an amide. Kind of like an amine, just one letter different, and we saw that amine group there. But now we just have this double bonded oxygen on the same carbon. And just how we did with carboxylic acids, if I can quit messing with my settings, the carbon that had the alcohol and the aldehyde group on it, that was guaranteed to be number 1. Same thing is going to be true over here. That has to be carbon number 1. Doesn't matter what else is on the rest of the chain. This determines number 1. So in this case, to name this, 1, 2, 3, 4 carbons. So we're still using bute. Looks like we have all single bonds, so butan. To name this amide, we actually just end it with amide. So this is butanamide. Just like that. Pretty easy. So now let's go through and make it a little bit more complicated. For some reason, my oxygens did not stick around. All right. So in this case, we have the amine group and the aldehyde on the same carbon. So just right off the bat, we know that's carbon number 1, 2, 3, 4, 5, and 6. All right. Looks like we have 6 carbons here. So I know that my base is going to be hex. Carbons are all single bonded together, so hexane. We can even name this part right away. They're both on the same carbon, the aldehyde and the amine group, so that means we have hexanamide. All right, so now I need to figure out what else is on there. Well, it looks like that's attached to it, and that's attached to it as well. Both of those are composed of 1 carbon, so each one is a methyl group. Together, they would be dimethyl. And in this case, I do need to indicate where those methyl groups are. I mean, there are, 1, 2, 3, 1, 2, 3, 4. There are 5 carbon choices for those methyls to go. So to indicate where they're at, we know that there's 1 on carbon 3, 1 on carbon 4, 3, 4, dimethyl hexanamide. All right, so throwing a little bit of a curveball at you. This group here, I know that I have my aldehyde and my amine group on the same carbon, so I know that part makes it an amide. But then over here, I have an amine group as well. All right, so when we did the amines, we did discuss how there were 2 ways to name them. One was you change the ending. The other one is you just stick it in front of the name. In this case, sticking this amine in front of the name is going to make this way easier. All right, so first things first, the amide group here determines the carbon. So let's go 1, 2, 3, 4, 5, 6, and 7. All right, 7 carbon group, because remember this bond isn't going to a carbon, so it does not count in the chain. This bond's going to a nitrogen. So our base is going to be hept, all single bonded together, so heptan. Amide there goes at the end, heptanamide. All right, so now this amine group here, To name it, we're just going to call it amino. Let's just kind of do one of those, amino. And that amino group is on number 7, so we have 7 amino heptanamide. Pretty easy, pretty straightforward. Like I said, the rules for the amides work just like they do for the carboxylic acids. Nothing new, nothing different. It's just being able to identify double bonded oxygen on the same carbon that's bonded to an NH2. That makes it an amide, which will change its naming. All right, with that, happy practicing.